Hello and welcome back to the final, well not final yet, but another Ivy Math speedrun with me, Vince. And so in this one we're going to be finishing up chapter 11.5 by talking more about the normal distribution. So let's jump right in. So the last thing we need to know about the normal distribution is how to reverse engineer it. So in the previous questions we got some mean, some standard deviation, and then from this we were given a value and we needed to find the probability that this function would be, like, say, less than or equal to this value. But what if we need to reverse engineer this? Say we're given two probabilities and we need to find from this the mean and the standard deviation. Well, we can do that as well. It's just a simple matter of rearranging, so let's jump right into some questions. So the first question is, if x if x is a normal distribution with mean 8 and standard deviation variance sigma, I don't have the sigma symbol squared, find the value of the variance given that the probability that x is less than or equal to 4 is equal to 0.321. Sorry about that. Anyways, so to solve this problem, we're given that the probability that x is less than 4 is 0.321. So we have the inverse normal, because we have to pass this probability back through the normal equation to get a value for the small z, because what we're saying here is that the probability of z is less than or equal to x minus the mean, 8, over the standard deviation is equal to 0.321. I mean 4 minus 8, sorry. So passing this back through, I get a value like 0.46. So 0.46 is equal to -4 over the sigma. So of course sigma has to be positive, so this is probably the wrong way around. But anyways, so sigma is equal to -4 divided by 0.46. -4 divided by 0.46, which is equal to -8.7 more or less. And so we need to find the variance. So we have sigma squared is equal to this squared, which I get as 75.6. So the variance of this is going to be 75.6. Okay, on to the next one. And we have the next question as a factory has a machine designed to produce 1 kilogram bags of sugar. It is found the average weight of sugar, should be mass, but okay, is 1.02 kilograms. Assuming that the weights of the bags are normally distributed, find the standard deviation of if 1.3% of the bags weigh below 1 kilogram. Correct to the nearest gram. So average weight, so we have the mean is equal to 1.02 kg, and we have the probability that this random variable is less than 1 is equal to 0.013. And we have to find the standard deviation. Okay, so what we have here is that the probability that z is less than x minus u, so 1 minus 1.02 divided by the standard deviation is equal to 0.013. So we have that this is equivalent to z being greater than 1.04 minus 1.02 divided by sigma, which is equal to 0.013. So we can get that I have 1.0, so 0.02 more or less, divided by the standard deviation is equal to, let's reverse engineer 0.013, which is 0.987, which is by my book around 2.22. So we have the standard deviation is equal to 0.02 divided by 2.22, which is around 9 grams. Because we multiply by 1,000, of course, so should be around 9 grams. Yep, that's correct. Okay, and then on to the final question. And the final question is the masses of broccoli stems sold at Jeans Green's online market are normally distributed with mean 320 grams and standard deviation 20 grams. So first, if a broccoli stem is chosen, I can't spell, at random, find the probability that its mass lies between 200 and 350 grams. Next, find the mass exceeded by 10% of broccoli stems. Next, in one day, 500 broccoli stems are sold. Estimate the number of broccoli stems that weigh more than 350 grams. And finally, at the nearby Kelbricks market, 15% of the broccoli stems sold weighed at least 400 grams, and not more than 10% weighed less than 370 grams. Assuming the mass M of the broccoli stems follows a normal distribution, find the expected value and variance of M. So quite a tall order, as you can see, so let's start. So mean 320 standard deviation. If a broccoli stem is chosen at random, find the probability that its mass lies between 350 and 300 grams. So we need to find the probability that this function z, like the normal function, is less than 350 minus 320, which is 30 over 20, and subtract the probability that z is going to be less than 200. So that is 320 minus 200. Sorry, 200 minus 320. 200 minus 320 being 120 over 20, which is insignificant. So anyways, we have the probability that z is less than 3/2. So that is equal to 0.9332. And we need to subtract from it. This is insignificant. This is like less than 0.0001. So effectively the answer is 0.9332. Okay, that's part number 1 then. Next, we have please stop lagging. Find the mass exceeded by 10% of broccoli stems. So we have x, the probability of z being greater than x minus 320 over the standard deviation is equal to 0.1, because that's 10%. So that equals x minus 320 over the standard deviation must equal 1.282. That's what I got. And so standard deviation, of course, being 20. So we have x is equal to 1.282 times 20 plus 320. So I got 345.64 as my answer. So that one. So yeah, that should be cool. And then on to the next one, where we have in one day 500 broccoli. Where'd it go? No, where's the question? Okay, in one day 500 broccoli stems are sold. Estimate the number that weighed more than 350 grams. So we need to find the probability that this will be greater than 350 minus 320. Sorry, greater than actually. Divided by 20. So it's greater than 1/5, which is equal to 1 minus 0.9332 is equal to 0.0668. So we would expect around 7% of the stems to be way more than 350 grams. So if we multiply this by the 500 stems sold, we would expect around 33.4 stems to exceed this value. Nice. And then on to the final question. And that's, okay, so 15% of the broccoli stems weighed at least 400 grams. So that means the probability of z being greater than 400 minus the mean over the standard deviation is equal to 0.15. And the probability that z is how many? Oh, not more than 10% and weighed less than 370 grams. So z is less than 370 minus u over this is equal to 0.1 or 10%. So we can translate these into two equations. So 0.15 1 minus 0.15, 0.85. So we need to find a value for that. 0.85, that's around 1.04. So 400 minus u over theta is equal to around 1.04. And then 370 minus u over this is equal to around negative 1.282. Yeah. So we have 400 minus u is equal to 1.04 times the standard deviation. And 370 minus u is equal to negative 1.282 times the standard deviation. So if we subtract these two, we get 30 is equal to 1.04 plus 1.282. So this is 2.322 times the standard deviation. So we have the standard deviation is equal to 30 divided by this value, which is around 12.9. Therefore, the mean should be 1.04 times this. 400 minus 1.04 times that. So the mean should be equal to 386.6. Yeah, so that was all for the speedrun. I hope you enjoyed, and I hope to see you in the next one, where we will tackle the Chapter 11 chapter review. See you then.